The purpose of this video is to show you how to graph your limiting reactant data. And so what you see here is a copy of a data table. I have not filled in columns 3, 4, and 5, even though you will have those filled in. You need that data in order to calculate column 6. But when you go to make your graph, you're only using the data from column 2 and from column 6. So column 2 is your mass of baking soda. That is going to be your X data. And column 6 is your mass of CO2, which is going to be your Y data. I've also filled in the colors from column 7, and the reason I did that is what you need to know before you graph the data is when your reaction is baking soda limited and when it's acetic acid limited. So what I've indicated here in words below the data table is that what I saw from both the visual inspection of the balloons and from when the solution changed color is that trials 1 through 4 were baking soda limited and trials 5 through 7 were acetic acid limited. So here I've taken the data from my notebook and I've put it into Google Sheets. And this first column, this is column 2 from my data table. So this is the mass of baking soda. And see how my words are extending past column A. So if I want to prevent that from happening, I just go over here to the right and I turn on something called text wrapping. The second column is the mass of CO2, but this is only the data that was baking soda limited. So for me, that was trials 1 through 4 were limited by baking soda. And so again, I can turn on text wrapping. And then this next column, this is the mass of CO2, but it's when it was acetic acid limited. So now that I have all my data in my chart, one thing that you should know is if your decimal places aren't showing up correctly, like this may go into Google Sheets and look like only 1.51, it may have dropped to 0. You can use these increase and decrease decimal places to add zeros at the end of numbers. And also, if you were to do this and you put your units right there in your cell with your numbers, it will not recognize this as a number. So Sheets won't be able to graph it. So you have to make sure you don't mix numbers and letters when you're putting numbers into a spreadsheet. So now I want to graph this. With Sheets, it's really better to select the words also as a title because Sheets is expecting that you're going to have some kind of labels in row 1. So I've selected all of my data, and then I just go to Insert Chart. And you want to make sure you have selected a scatter chart. There's a lot of options here, but the scatter chart is the correct chart generally in science. So here I have a scatter chart selected, and what I want to do is I'm just moving this over, I want to customize this a little bit. So I'm going to the Customize tab up top, and I go under Chart and Axis Titles. So for chart title, usually it's not going to pick a good name, so you need to rename your graph appropriately. So I'm just going to call this title, so you can figure out your own title. If you want to center it, come down here to Alignment, and then that word will become centered. For my horizontal axis title, in this case it did select a proper title for me. Vertical axis title, it hasn't put in anything, so I need to put in some kind of a y-axis title here. And then what you need to do is you're going to need to put in a trend line. So we're going to go to Series. We opened up the Series tab, and we don't want to apply to all series. What we want to do is we only want the mass of CO2 where it was baking soda limited. That's where we want to get the trend line for. So select that series and then come down and you click trend line, and then you have these options to show the equation, show the R squared on the chart, and for the label you're going to say use equation. And then that should be all that you need to do. So you're going to have to just go through, edit the y-axis title, make sure the x-axis title is correct, put a proper title on your graph, and then this equation for the line, this is of the form y equals mx plus b, so it's y equals 0.483x minus 3.8 times 10 to the minus 3. And this R squared value, this shows you your goodness of fit. So this equation here is what you need to continue on with the calculations.